My name is JC, and I am the Public Programs Manager here at the Rory Myers Children's Adventure Garden at the Dallas Arboretum. We are here at the Wall Family Discovery Lab, where today we're going to be doing a fun experiment called a mixture of solutions. What I'm going to do is step over to my overhead camera so that way you can join along at home and get a closer look at all of the experiments. I'm going to have my friend Laura switch the cameras, and I'm going to head over to the experiment station now. See you in just a sec. All right, everyone, here's what we're going to do. We've got a bunch of different materials here. But before we begin, we need to talk about what makes up mixtures and solutions. Matter. Have you heard that word before? Matter? Matter is anything that has mass, volume, and takes up space, just like this corn kernel. Everything is made of matter. Now, do you know the 3 primary states of matter? Let's see if we can find a few examples around me right now. I wonder which of these things is hard and doesn't change shape. I think this popsicle stick is like that. This is something we call a solid. It doesn't move. It tends to hold its shape. Yeah, this is definitely a solid. I wonder what else we have. Oh, I know. My water is a little bit different. When I move it, it actually changes shape based on what the container is that it's inside. I think that makes it a liquid. It flows and changes shape with its container. The last primary state of matter is in this bowl right here. Can you see it? Wait, you think it's empty? Well, it looks empty, but that's just because it has air inside. You can't see the air, but there's a whole bunch in there right now. So we've got solids, liquids, and gases, and we can mix them all up. All right, do you have all your materials ready now? Because you're going to need your small solid objects first, like pebbles or beans. I am using these beans right here. I'm also using corn kernels. Miss Laura, what else could people use?
Maybe like 2 kinds of breakfast cereal.
Oh, that would be fun, mixing cereals. All right, I'm going to take these 2 things and I'm going to pour them into my bowl. All right, now I'm going to take my stirring stick and stir them around. What do you notice? Is it messy? Maybe noisy? I'm going to see here. Can you tell your 2 different items apart still? Can you still separate the 2 things? I'm going to use my hand now, and I'm going to see if I can separate the beans and the corn. Go ahead and see if you can separate your items as well. Let's see here. I can pull out all of these beans, and then maybe when I'm done with that, all that will be left is the corn. Oh, I'm so close. Do you think you can finish before me? Oh no, I think it's a race now. I have to go fast. Oh, just 3 more, 3 more. All right, 1, 2, and 3. I did it. I separated all of the corn and the beans again. Interesting. Now, when we poured these 2 things into the bowl together, we stirred them up. But what's another name for when we do that? Maybe a word that starts with an M? Mixed. Oh, that's right. We mixed them together. That's why this is called a mixture. When you put two or more types of matter together. Interesting. Mixtures can be made with solids like these, liquids, or even gases. Any combination will create a mixture. I wonder if there's any mixtures around us right now, like the dress that I have on underneath my jacket. It has two different types of fabrics mixed together in threads to make it stretchy, but also soft and warm. Even the air around us right now has multiple gases like nitrogen and oxygen mixed together. Have you ever had a soda before? That's a mixture of a liquid, a gas, and a solid. How cool is that? Now, an interesting fact about mixtures is they can always be separated back into their original forms of matter. So let's take a look back at the mixture of pebbles and beans. We separated it, right? It worked great. So let's go on to the next part of today's lab. We're going to make another mixture. This time, you're going to need your water. Now, we originally thought we might need 4 teaspoons of water. However, when we tried the experiment earlier today, we found it actually worked a little better with 6 teaspoons of water. So if you've got any extra water at home, you may want to have your parents put just a little bit more in there for our experiment today. You are also going to need your salt. And I have here 2 teaspoons of salt. So what we're going to do is take our salt and we are going to pour it into our water. Here we go, just a little bit at a time. I'm going to shake it in, shake, shake, shake. All right, it's all the way in now. What do you observe or what do you notice? Does the water look any different now? It's a little bit cloudy, and it also looks like a lot of the salt is sticking here in a big clump. It isn't mixing very well. Maybe we need to stir it. Grab your stirring stick or your spoon, and we are going to stir, stir, stir. Now, as you begin to stir, your mixture may look a little bit different. Whoa! It looks like those salt crystals are beginning to disappear. I wonder why that is happening. What do you think? Why do you think the salt is beginning to disappear? I think I know. It's because the salt is dissolving. Have you ever heard that word before? Dissolve? As you continue to stir, the salt crystals are breaking down into tiny, tiny pieces called molecules. Those molecules are so small that they begin to mix in with the water molecules to create a mixture. But this is a special kind of mixture. It's a solution where you take one substance and dissolve it into another one. In this case, we're dissolving it in water, which we like to call the universal solvent because it can dissolve so many things. Now, a solution is a little bit different than other mixtures, like when we mixed our corn and beans. Solutions, you can tell them apart from a regular mixture because, number one, it's uniform. It looks the same everywhere. So when we look in the water, once the salt is completely dissolved, it just looks like kind of cloudy water again. You can't see the salt crystals anymore. Whereas when we mixed the corn and beans or other solid objects, you could still tell them apart. The other thing about solutions is they're stable. It means they don't change or settle to the bottom. If I were to put one of these beans and drop it into the water, would it settle to the bottom or mix in with it? That's right. It would settle and fall and sink to the bottom. The other thing that's cool about solutions is the dissolved particles are so small they can't be separated by filtering. So if I was to take this bean and drop it in the water, Could you filter it back out? Sure, that's because it would just be a mixture, not a solution. The only way we can get the salt out of here is by very special technology called evaporation. So our salt water is both a solution and a mixture, but our pebbles and beans were not a solution. All right, very good. We've done so much science, and now we're ready for the final experiment. Okay, last steps. We are going to mix multiple magical mixtures. Try saying that 3 times fast. We're going to start by taking our flour. Now you should have 4 tablespoons of flour, and we're going to pour it into our bowl. Next, we have 1 teaspoon of cornstarch. Cornstarch looks a lot like flour, but it's made from corn, whereas flour, like this, that we have, is made from wheat. I'm going to just pour that cornstarch in. There we go. And I'm going to give it a little mix with the dry end of my stick here. What do you think? Is the cornstarch and flour a solution or a mixture? Oops. If you get a little messy like me, that's okay. Science can be messy sometimes. All right, now I'm going to take 2 teaspoons of oil, and I'm going to pour that into my dry ingredients. Just a little bit. Now, I'm going to take my stick and begin to stir it in. Now, that was just a little bitty bit of liquid for a lot of dry ingredients, right? So we are going to add more liquid. Now, before we do that, I'm going to get a little bit of green food coloring because that's what color I love. You can use whatever color food coloring you'd like. I'm going to put 3 drops. Here we go. 1, 2, and 3 right in here, and I'm going to give it a good stir. We want to make sure that the food coloring and the water and the salt are all mixed together in a nice uniform solution. Awesome work, everyone. Now things are about to get even better. What I'm going to do is take my water here, and I'm going to take the solution and pour just a little bit at a time into my dry ingredients, and then I'm going to stir it. Let's see what's happening. I can see little bits of green here, but it's still pretty dry. Let me add some more water. Oh, very good. We're going to keep stirring. Whoa, it's getting even more green. How cool is that? All right, we've got a little bit of water left here. I'm going to add that in. There we go. And give it one more stir. Wow, this is getting pretty cool. Now's the time where you get to be a little messy. Not too messy. Ask your parents first how messy you can be. All right, I'm going to take my hands and I'm going to use them to start grabbing some of the clumps in here and squeezing them together in my hand. If your mixture is a little dry, you can always add more water. Miss Laura is going to grab me a little extra because I'm a little crumbly today. What color did you make your mixture today? Red, orange, yellow? Green like me? Maybe even blue or purple or pink? All right, now I'm going to take my dough here and I'm going to make a little hole in it because I need a little extra water. I'm just going to put it right here in the middle. And then I'm just going to fold it around it. Ooh! Now, as you continue squeezing here, you might notice your dough gets a little sticky, but don't worry. As you continue to squeeze it or knead it, it will become more dry and dough-like. It's already beginning to do that now for me. Take a look at the color of your dough. Is it the same or different as when you began making it? The color of the flour here in my bowl compared to the color of the dough in my hand is a little bit different. How neat is that? So, as we continue to squeeze, it's actually very important that we work the dough like this. Whenever you make dough, like maybe bread dough, you have to knead it because the wheat in the flour has something special inside called gluten. And you have to stretch it in order to make the bread stretchy and springy. So by kneading our Play-Doh, it's actually going to make our dough stretchy and springy too. So let's take a look at our final product. How cool is that? It's your own ball of Play-Doh. Now, because we've been talking about this all afternoon, I have the million-dollar question for you. Is this Play-Doh a mixture or a solution? Well, in order to be a solution, what did we say needed to be mixed together? Oh, I remember. One substance has to be mixed into a solvent, usually a liquid like this. Well, did we mix the flour and cornstarch and oil into the water? No, we did it the other way around. So what we made is actually something called a colloid. Now, what's a colloid, you say? Well, that's what happens when you mix a liquid into a solid. It doesn't change the type of matter it is, but if you look at it mixed together under a microscope, it would actually look like a solution. So this is actually a type of gel because it's more solid than liquid and it's really squishy. Oh, that's a lot of science for today. Let me pop back over behind the counter and talk to you a little bit about what we're going to learn next week. All right, everyone. I hope you had fun today learning about a mixture of solutions. Join us next week, 4 p.m. next Tuesday, for our next Discovery Lab Live, Catalyst Catastrophe. It is going to be a blast. I hope I didn't give away too much. Make sure you check our list of ingredients on Thursday on Facebook, or you can go to dallasarboretum.org and sign up for the Rory Myers Children's Adventure Garden email. And that will also have your weekly ingredient list too. If you're watching this live right now, or if you're watching the playback, don't forget to leave a comment below and we'll answer all of your fun science questions. Remember, I'm JC, this is Discovery Lab Live, and we hope to see you soon in the garden. Bye-bye, everyone.